Hello everybody, welcome to my channel Maths Insider. Today we're going to discuss about coordinate geometry class 10 part 2, which basically the extension of part 1. We'll take different examples and we will see more and more concepts solving the problems, and let's get started. Today we are going to discuss about the following topics: about the coordinate geometry part 2. So where we will discuss more examples using the distance formula, and we know the distance formula AB is given by the square root of the difference between the x-axis square plus the difference between the y-axis square of the 2 points. So today the example which we're going to discuss is about the missing coordinates, that is either the x coordinate is missing or the y coordinate is missing for a given points. Secondly, we'll try to find the value of k, where k is a part of either x and y coordinates for a given points. Then we'll try to see some examples on relation between the x and y coordinates forming the equations. And the fourth important points there are two important points which we need to will discuss. There any point on the x-axis will take the form of x and 0. So which states that any point on the x-axis will have its y coordinate 0, and any point on the y-axis will take the form of 0 and y, which implies that all the points on the y-axis will have its x coordinate 0. So with all this, let's start and with our examples and the concepts. So the first point which we're going to discuss in today's session is about the missing coordinates. So we can take an example by which we can able to see what is this missing coordinates and how we can able to find its value. So in this given example, it is given that find the value of y for which the distance between the points A, which is 3 and minus 1, and point B, which is 11 and y, is 10 units. So let us represent these 2 points in this Cartesian coordinate, and then we'll discuss how to find this missing coordinate y. So this y is basically the missing coordinates. So point A is given by 3 and minus 1. So 3 in the x-axis is here and minus 1 is here. So this is my point A. So I can write A here, and the value given here is 3 and minus 1. And the point B is basically 11. So basically it is here somewhere, and we don't know the value of y. We need to find it. So let us take point B as here. So B is nothing but it is 11 and y. So if we join these 2 points by a line, it will give me a line like this. So basically we need to find this line, and in this problem they have given the distance between these 2 points is 10 unit. So basically this distance is my 10 units. So this is 10 units. So with this given points, we will try to find the missing coordinate y, which is this one. Now let's use the distance formula. So we have the distance AB is given as AB is equal to, I'm writing the generic formula, root over of x2 minus x1 square plus y2 minus y1 square. Now, if we consider point A and B, we can write the coordinates like this. X2, say for example, is equal to 11, and X1 is therefore will be equal to 3, and Y1 is basically equal to -1, and Y2 is our missing coordinate, that is Y. So this X1 and Y1 is representing by A, point A, and this X2 and Y2, this represents point B. Now using this, I can put the value in this equation, which is the distance formula. So we can put X2 as 11 minus my X1 is 3 and its square, plus Y2 is basically Y minus of -1 and the square of it. So therefore we can find to be 11 minus 3 square plus Y minus and minus, it will give me +1 square. And as per the problem, it is given that AB is basically, this distance is basically 10 units. Now if I consider this equation is to be equation 1 and this equation is said to be equation 2, so therefore we can write 11 minus 3 square plus Y plus 1 square equal to 10. Or now I am just simplifying this equation. So with this whole thing, we have formed the equation, and this is a linear equation, and if we solve this equation we can easily find out the value of Y. Therefore, so 11 minus 3 is basically 8 square plus Y plus 1 whole square equal to 10. Or this is 64 plus Y plus 1 square equal to 10. So if we square both the side, squaring both the sides, so this will become 64 plus Y plus 1 square equal to 10 square, which is equal to 100. Or 64, now I am expanding Y plus 1 whole square is basically Y square plus 2 into Y into 1 plus 1 square equal to 100. So this whole thing is basically A plus B whole square, which we have already read in the primary class. So Y square plus 2Y plus 1 which is equal to 100 minus 64, which is equal to 36, or this again we can just contract it. 5 plus 1 whole square is equal to 36, and if we take the square root, it will be equal to plus minus root over 36, which is equal to plus minus 6. Now we have y plus 1 equal to plus minus 6. So from where we can able to see that y plus 1 equal to plus 6, or y plus 1 equal to minus 6. Therefore, y is equal to 6 minus 1, which is equal to 5, or y is equal to minus 6 minus 1, which is equal to minus 7. Hence, required value of y are 5 and minus 7. So what we have understood is that we have to first understand the problem, and then we have to see what are the missing coordinates and what are the relationship of the different points in the given problem along with whatever distance they have given. And second thing, after knowing these informations, we have to frame equations, and then framing the equations we can able to find the unknown coordinates. Second important topic is about finding the value of k, where k is a part of x and y coordinates. So if we look at in the example, so it is given, so you have to read the problem very carefully before we proceed for solving it. So if the point P is equidistance from the points A, which is 3k, and B, which is k and 5, find the value of k. So if we look in this whole problem, we can find that in each of these points, that is P, A and B, there is a value k, which basically form the coordinate either x or y. Like for example, in P, we can see that x coordinate is formed by k minus 1. In point A, we can see that y coordinate is formed by k. And in point B again, we can see that x coordinate is formed by the value k. So we need to find the value of k. So to do this, we will just trace out the problem, the points here. Like say for example, if this is my P point, which is k minus 1 and 2, and we have other point which is A, and this point is given by 3 and k, and we have point B which is given as k and 5. Now let us draw this straight line from P to A and P to B. So, and according to this whole problem, it states that P is equidistant from point A and point B. So my PA is basically equal to PB. So there are two important steps here. So first we need to find the distance of PA and PB. So step 1, we can break this whole problem to simplify it into two steps. So first step 1, which is basically tells us about finding each distance, find each distance PA and PB using the distance formula, using the distance formula. So let's find the point PA and PB. So first I'm trying to find PA. So now by this time we are now very much familiar with this equation, distance formula. So if we consider this P as x2 and y2 and A as x1 and y1, so we can take the square root of that and put k minus 1 minus 3, that is square, plus 2 minus k square. So which is nothing but square root k minus 1 minus 3 is minus 4 square plus 2 minus k square. So this we consider to be equation 1. Similarly, let's find PB. So PB, again, if we consider this to be x2 and this to be y2 and B as x1 and y1, so again using the distance formula we can easily write k minus 1 minus k square plus 2 minus 5 square. So now plus k and minus k, it will cancel each other. So therefore we have minus 1 square plus 2 minus 5 is minus 3 square. So which is basically equal to root over of 1 square is 1 and minus 3 square is 9, and this gives me square root of 10. So this is my equation 2. Now secondly, we know from this problem that PA and PB are equal. So now we have to frame the equation. So step 2, is the relation between PA and PB, which is PA is equal to PB. So that is equation 1 is basically equal to equation 2. So what is my equation 1? So this is my equation 1. So I can write square root of k minus 4 square plus 2 minus k square is equal to my root over 10. Now squaring both the side, squaring both the side, what we'll get? We'll get k minus 4 square plus 2 minus k square equal to 10. Now we will expand each of this square, that is a minus b whole square. Again, we are familiar with this a plus b whole square and a minus b whole square formula. So this will be k square minus 2 into k into 4 minus 4 square plus this will be plus 2 square minus 2 into k plus k square equal to 10. So this comes as k square and k square is 2k square, or 2k square minus 8k, 4 to 8k plus 16 plus this is 4, again this is minus 4k equal to 10, or we have 2k square minus 8k and minus 4k is 16k, and we have plus 20, and we are taking 10 from right hand side to the left hand side, so it will be minus 10 equal to 0, or we have 2k square, this will be 8k, 12k minus 12k plus 10 equal to 0. Therefore I'm just taking 2 as common, so k square, this will be 6 to 12 plus 5 equal to 0. Now this equation what we got is very familiar with our square functions. So what we can do is that we can able to break these equations as k square minus 5k minus k plus 5 equal to 0. So the multiple of this k is equal to minus 5 and minus 1. So minus 5 into minus 1 is plus 5, and it also holds good for minus 5 and minus 1 as 6k. So this equation holds good. So we are taking k common, so k minus 5, and we are taking minus 1 common from this kn plus 5, which basically give me k minus 5, which is equal to 0, or k minus 5 and k minus 1 is equal to 0. So this gives me two value of k. One is k minus 5 is equal to 0, or k minus 1 equal to 0, which implies that k is equal to 5 or k equal to 1. So the value of k that is required to found in this particular problem, value of k are 5 and 1. So again, what we have done is that we have break this whole problem into two steps. So in the first steps, we have find each of the distance PA and PB. And in step 2, we know the relation between PA PB is that PA is equal to PB. So therefore, the equation 1 is equal to equation 2. So we have then put the equation 1 is equal to equation 2 and we solve this equation, and after solving this equation we can able to find the value of k. So now we are coming to point number 3, basically where we'll try to find the relation between x and y coordinate by forming an equation. So again, to do that we need to carefully read the problem, and from the problem itself we can able to get a clear idea how to frame the equations using the x and y coordinates of two different points or using different points. So if we read the example here, which is given as find the relation between x and y such that the point P, which is denoted by x and y, is equidistance from points A, which is 1 and 4, and B, which is -1 and 2. So this problem is very much similar with the previous problem where we find the value of k, but here it's not actually finding the value, rather than we are forming the equations. So here there is a little bit trick. So again, to frame this equation, what we need to do is that we need to first break this whole thing into steps. So first of all, let's see the point P, which is given by x and y, and we have point A, which is given as 1 and 4, and we have point B, which is given as -1 and 2, and we can join these two points PA and PB. So basically this PA is equal to PB once again. That is equidistance from point A and point B. So this P is basically equidistance from point A and point B. So again, step 1, let's find PA and PB using distance formula. So what is PA? So if we consider this P as x2 and y2 and A as x1 and y1, so we can take the square root, and under the square root we have x minus 1 square plus y minus 4 square, and we can consider this to be equation 1. Similarly, if we frame PB, we can write PB as square root, and this is x minus 1 square, because this is B is -1, plus we have y minus 2 square. So we'll solve a little bit here. So here x -1 and -1 and minus to be +1 square plus y minus 2 square. So this is my equation 2. So now in step 2, as in the earlier case also, what we did is that we tried to find the relation between PA and PB. So we know their equidistance. So PA is equal to PB as their equidistance. So therefore, equation 1, in short I am writing equation 1 is equal to equation 2, which is here. So these two equations are equal. So we can write square root x minus 1 square plus y minus 4 square to be equal to square root x plus 1 square plus y minus 2 square. Or we are squaring both the side, squaring both the side. We have, so this square root will be removed and we are having x minus 1 square plus y minus 4 square, which is equal to my x plus 1 square plus y minus 2 square. So this gives me, so now I'm expanding this x minus 1 square and y minus 4 square, or x plus 1 or y minus 2 in the form of a plus b or a minus b whole square respectively. So this x minus 1 as x square minus 2x into 1 plus 1 square plus, I'm expanding this as y square minus 2 into y into 4 plus 4 square. This is my left hand side, and on the right hand side again I will expand this as x square plus 2 into x into 1 plus 1 square, and then I am expanding this y minus 2 as y square minus 2 into y into 2 plus 2 square. Or so this x square and this x square will cancel from left hand side and right hand side because they have same sign, that is positive. So also the y square will cancel up. So we have on the left hand side as minus 2x plus 1 and minus 8y, this 8y plus 16, and on the right hand side I have 2x, so this 2 into x into 1 plus I have 1, then I have minus 2 into 2, that is minus 4y, and I have plus 4. So now I'm taking all the values of the right hand side to the left hand side of the equation and see how the equation looks like. It is minus 2x minus 2x minus 8y and this minus 4y will become plus 4y when I am taking to the left hand side, and this is 16 plus 1 17, and this 4 and 5 which will go here as minus 5, and this becomes equal to 0, and we have the equation as minus 4x minus 4y plus 12 which is equal to 0, or we have, now we are taking 4 common, so we have minus x minus y 4 3 are 12 equal to 0, or if we subtract multiply the left hand side and right hand side with minus 1, so then minus x into minus 1 plus x y minus 3 equal to 0, or y is basically equal to taking 3 there to the right hand side and x. So I got the relation between x and y to be y equal to 3 minus x. So this is the required equation which we have derived from the condition that is given, which is that this two point, that is point A, is equidistant from point B and point A. So the last point that we'll discuss today are these 2 points, which basically will tell us about any point on the x-axis will take the form of x and 0, which implies that the y-coordinate of all those points will be 0. So this means here we have uh, all the points which are there in the x-axis, they will take the form of x and 0. This implies that my y coordinate will be 0, and any point on the y-axis will take the form of y and 0, which implies that my x coordinate will be equal to 0. So with this, we'll just try to show you in a Cartesian coordinate how these points how these points will have this form of x and 0 and 0 and y. That's me. So now if I locate any point here, say for example in this x-axis, so this is my x-axis, so this is the origin, and this is the y-axis. So if I want to locate a point on the x-axis, say P, so what is the value of y? So y is basically 0, and what is the x? It is 6 and 0. If we try to locate a point here at the 3, say for example A, so here x value is 3 and y is 0. Similarly, if I try to locate any point on the y, say for example here, say B, what is this? So my x value is 0, and what is the y? It is 7. Similarly, if I want to find any value here, say it is t, which is basically my x-axis is 0, but y is minus 4. So this is actually what is been stated here. So therefore, what we can see is that, so any point on either of the x-axis and y-axis will have its other coordinate being 0. So any point which is lying on the x-axis will be its y coordinate 0, and any point which lies on the y-axis will be its x-coordinate to be 0. So using that, we'll try to see and solve one problem which often comes or we encounters. So what's the problem? So it states that find those points on x-axis. So there may be more than one point on the x-axis, each of which is at a distance of 5 unit from the point 5 and minus 3. So for example, here I have to find more than one point. So let's say for example I'm taking a point in point, say C here. So what would be my coordinates? It will be x and y is obviously 0, and there is point A which is basically 5 and minus 3. So this is minus 3 and this is 5. So this is basically point A. We need to find this distance. So A is basically 5 and minus 3, and C is x and 0. So again, what we will do is that in this step 1, what we need to see, we have to visualize the location of each point. So we have to visualize the location of each points. So from here, C is my point on x-axis, and it is given by C, x and 0. And we have point A which is given by A, 5 and minus 3. And what is the second step we need to find? We have to find the relation between these two. So the relation is CA is equal to 5. So it is given here that points on the x-axis, each of which is at a distance of 5 unit from point A. So C is at a distance of 5 from A. So CA is 5. So getting this information, step 3 is, let's find CA using distance formula. So we know the distance formula, x2. I'm just reiterating it to make ourselves more and more familiar, and y2 minus y1 square. Now we know from the above C is x and 0 and A is 5 and minus 3. So taking the square root, so x minus 5 square plus here y is 0 minus of minus 3 square, because it is given minus 3. Therefore we have x minus 5 square plus minus and minus 3 is plus 3 square. So this will be my equation. Say for example 2, if I consider this as equation 1, Therefore, we have x minus 5 square plus 3 square is 9. Now in step 4, we have to make this equation 1 to be equal to equation 2. These two are equal. Therefore, we form the equation plus 9 equal to 5. Now once we form the equation, it will be easy for us to solve it. Now squaring both the side, we have x minus 5 square plus 9 equal to, this is 25. Or now again, this is our basic formula a minus b, that is x square minus 2 into x into 5 plus 5 square is nothing but 25 plus 9 equal to 25. So this, in from the LHS and right RHS, what we can able to observe, that plus 25 will get cancelled, and we are having x square minus 10x plus 9 equal to 0. So how we can break this equation? So you have to break into middle term factors. This is the middle term. So we have to break in such a way that the multiple of this 2 will get the value of plus 9 here, and also it will satisfy this value minus 10. So how we can do? X square minus 9x plus, excuse me, minus x. So minus 1 into minus 9 is plus 9 if we multiply it, and minus 9 minus 1 will give me 10. So it is satisfying my middle term factor. And now I'll take out x from this factor, and it will give me x minus 9, and from this 2 I'll take common as minus 1, which will give me x. This will become plus x, and this will become minus 9 equal to 0, and then this x minus 9 is common, and this will become x minus 1 equal to 0. So now I have two equations. So x minus 9 equal to 0, or x minus 1 equal to 0. So, or which give me x equal to 9, or x equal to 1. So therefore, what I found is that if I say this, so there will be 2 points. So C and B, basically C has 2 points. One is 9 and 0, and another is C, which is 1 and 0. So here is 1 point, say C 1 and 0, and here is another point, C 9 and 0, which is basically equal distance from A which is nothing but 5 and minus 3. 5 and minus 3. So this distance, these are equal as per the problem. So this is equidistance from A. Hence, the 2 points are C 9 0 and C 1. So from today's session, what's the summary that we can able to make is that we have solved more problems using the distance formula. So this gives us more and more concept how we can able to utilize the distance formula to find the missing coordinates, to find the value of k, and to find the relation between two coordinate x and y. So in all these three equations, the major thing is that we first need to see the distance formula, that would be one point, and the second thing is that we have to frame the equations. So we need to understand each of the problem very carefully, and using the distance formula we'll to first find the distance of the points, and then there will be certain conditions whether those points are equidistant from some other points, or maybe there are some other conditions. So using those conditions we have to frame the equation. So once we frame the equation, it will be very easy for us to find the value. And then we have discussed on the two most important points, that is any point on the x-axis will take the form of x and 0, which implies that the points on the x-axis will have its y-coordinate 0, and any points on the y-axis will take the form of 0 and y, which implies that the x-coordinate of all the points on the y-axis will be 0. So hopefully that gives some glimpse and clearing the concepts of using the distance formula, and also how we can not only use the distance formula, we uses the conditions to frame the equations with along with the distance formula, and we tried finding the equations, and from the equation we solves the values of k, x, y, and the relation between x and y. Hope that will really help you to use these concepts and help to solve the problems. And if you really like it, please help to subscribe, and we will try to solve the problem together. And if you have any queries, please feel free to give your queries in the box. Thank you.